Hello guys, welcome to this programming language for absolute beginner video. In this video we'll be looking at closure. Closure is a self-contained block of code that can be passed around and used in our code. In this video we'll be looking at the general closure syntax. We'll look at the trailing closures. We'll look at when we have multiple closures, how do we handle it. We'll look at capturing how closure capture value. We also look at escaping closure. Without further ado, let's move into our S code. Now in S code, we are going to start with the general closure syntax. So to express this, let me comment this line out. Now, here is the general closure syntax. We introduce our curly braces, then we indicate the parameters, and the type of this parameter will be infer from the context where the closure is being called, as you will see. Then we indicate our return type. Say this return type. And then we now use the keyword in and then the statement. Now, this is the general closure syntax. This is the form it takes. Now, let's consider this example. Let's say we have an array of animals. Let me this one. Let me this one to be var. Let me call this animals. Let's start with. Let's call this dog. Say and cow, cat. Now, let me declare another variable. I want to assign this after sorted. I want to assign it to another variable. Let me say sorted animals. Again, let's assign this. Now let's say animals, and then call the sorted method sorted. Now, this method takes in a closure that takes in two parameters and then return a boolean. That's what sorted. To write the closure syntax here, we can do curly braces. Then if first, like said, we are going to indicate our parameter. Now let's give this parameter S1 and the other parameter let's call it S2. Then we indicate our return type. Then we now use the keyword in and then we have our statement. So in this case, let me just say S2 greater than S1 so that I can have this array in an alphabetical order. Now, let me print this to the console. It's sorted. Now let me run this. Now we cannot see that we have our animals sorted in an alphabetical. We have cat, cow, dog, hen in an alphabetical order. Now we can so oftentimes we'll see when we see visual expression in maybe in legacy code, we will see it in this format. For example, now I can take out the return type. You can also as well remove these braces. And then the code, if we run it, it should still work. So we can see we still have our array sorted. Also, if it's just a simple expression like this, we can even use the dollar sign to represent the parameters. So let's look at this now. We can also rewrite this as dollar sign O1 is greater than, in this case, only the dollar sign 1 is greater than dollar sign 0. Now, the dollar sign 1 represents the second parameter, dollar sign 0 represents the first parameter. So, and if we have three parameters in our closure, that means we have dollar sign 0, dollar sign 1, and dollar sign 2. So if we run this code now, we should still expect it to work as usual. Our array should still be sorted. Now we can see that we still have the array sorted. Now let's look at trailing closure. Again, I'm going to use this as an example. This array should declare for trailing closure. Sometimes when we have a closure that is defined as the last, that is passed as the last parameter in a function, you can use the trailing closure syntax. And we will see this a lot in SwiftUI, especially when we use something like H stack, V stack, all those things. They all use trailing closure syntax. So to convert this now to the trailing closure syntax, we can simply just remove this from here and then remove this. So if we run this should still work. So this is the trailing closure syntax for. Now you can see we still have this detailed out. Now let's consider this example. Let's declare an array of numbers and let's just talk more about the trailing closure syntax. Let's say var. Let me just call this numbers. So square braces, and then I just put maybe some 1, 4, 3, 6, 7, 9. I just leave it that way. So now there's a map method on that comes with as part of an array type. So if let's say we have now, let's square number. Let me just call this num, and then assign it to, now let me say numbers dot map. Now inside this as well, we can use a trailing closure syntax. Then we can say this, and we can just say, then we now say num, which will be the parameter, and then the keyword in. Then we can now say return num times num. So if we run this now, let's print the square num into the console. So let's print square num. Now let's run this. Now we can see that we now have all the numbers inside the array squared. So that means 2 times 2, 4, 4 times 4, 16, 3 times 3, 9, like that. So now let's move to value capturing. For that, let's consider this function. Say function, func. Let's call the function string generator. Just put string generator. Now let's pass in a single parameter inside this of type string. Let's call this s1 of type string. Now this is going to return a closure. So for that, a closure that takes no parameter and return a string. Then curly brace. Now let's declare a local variable inside this. Let's say var. Let's call it full test and assign it to an empty string. Now, inside this now, I want you to declare another function inside this function. So let's say fun. Let me call this concat. See, let's just call it concat. And then this function return a string. It takes in nothing, and then return a string. Curly brace. And then what I wanted to do is to concatenate every single test that was passed into this function will be added up to with one another. So say full test, assign it to full test, and then let's concatenate so there will be space in between them. So re x1, which is the parameter we pass into the function. So now I'm going to just return undo. So I'm just going to return the full test. Return full test. Now in this function, we are going to return this function which we declared. You can say return concat, return concat. Now you can see that this. Let's look at this inner function. This inner function concat. The variable here was not defined inside it. But one thing about closure is that it can pick up it can capture the value of the surrounding context and use it inside its own statement. So now let's bring this to the console. Let's just first call the function and pass in a string. So let's string, let me just call it con, assign it to the string generator. String generator, then we have to pass in the s1 variable, s1 colon. Then let's just give this let's call it Thomas. Now let's bring this to the console. Let's say print. No, with this function return a function, so we have to call that function for it to run. Let's say string long, and then open and close the bracket. So let's run this and see what we have. Now you can see we have Thomas. Now let's call this again. You can see what we have. So I can see what we have. You can see this continue. The string continues to add up. If I call this method again, you can see now we now have Thomas. Now, what I want to mention here is that a closure is a reference type. That is, when we copy a closure, I think closure is passed by reference. So, and that's why each time we call this particular closure, it's still the same thing because it's only we only have it's a reference type. So now to prove that, for example, let's reassign this to another variable. Let's just call it variable. Let me call it string con2. and then assign it to the string con, the one we defined earlier. So now, because if you now print string console to the console, you will see that the name will continue. It will continue from where we stopped before. You know we have 3 Thomas concatenated to 4, but now we should have 4. So let me just print string console to the console. String console. Yeah, let me print this to the console. Now we can now see that we now have Thomas now in 4 places. You can see we have Thomas, 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 Thomas. So it's still the same expression because it's still the same variable that we passed before. Because when we copy it and pass it to another variable, we are only copying the reference to it. That's why closure is a reference type. And now finally, let's look at escaping closure. So with escaping closure, what we do is that we ensure that a closure is not called until when the function which defines that closure is returned. That's what we do. And the syntax is this. Let's just look at this. Let's say var. I want to declare a variable that just take. Let's call this handlers. And then call this just return void. And then assign it to an empty array. Now let's declare a function that takes in the closure. The escape. Let's call the function escaping closure. Then let's assign this. Let's call this completion handler. Then let's use colon. Then at escape. So to escape a particular closure, this is what we do. We start at escaping. And then we put our closure, which takes no parameter, and then return the void. So can I say handler dot append completion handler, and then we return the function. So we return it. So now what we just did here now is that this particular closure is not going to be called until when this function returns. And this is very useful when maybe in our function the closure we pass is we process maybe a network call or something. So this is where this is very useful. So the function the closure will only be handled after the function has been returned. So guys, thank you. This is the end of this video. Please don't forget to subscribe, like, comment, and share. See you in the next video.